Hey everyone, I'm Anesha from IBM, and today we're going to be talking about an introduction to artificial intelligence. So what exactly is artificial intelligence? The definition we'll give today is that artificial intelligence is the capability of a machine to imitate human intelligence. So it's a branch of computer science dealing with the simulation of intelligent behavior. What exactly does intelligent behavior mean? How can we classify human intelligence? AI systems will typically demonstrate at least some of the following behaviors associated with human intelligence: planning, learning, reasoning, problem-solving, knowledge representation, perception, motion, and manipulation, and to a lesser extent, social intelligence and creativity. If we can imitate human intelligence, what can we do with it? Here are some examples of AI systems existing today or that may exist in the future. Some of the things you may be familiar with include chatbots, self-driving cars, being able to predict the future, AI doctors, speech recognition, or even AI music composition. AI itself is a big term and encompasses a lot of things. So breaking down artificial intelligence, machine learning is a subset of AI that refers to AI systems being able to learn without being explicitly programmed. Another buzzword that comes up often is deep learning, and that's just a subfield of machine learning that uses neural networks to simulate human decision-making. So going into the definition of machine learning, we can say that, evolving from the pattern of recognition and statistics, machine learning is the field of building models to classify and make predictions from data instead of following rules-based algorithms. So, what does that mean? Let's go into an example of a problem we may be able to tackle with machine learning. What if we wanted to determine whether a heart can fail? Is this something we can solve with machine learning? The answer is yes. Let's say we are given data such as beats per minute, BMI, age, sex, and result, whether the heart has failed or not. With machine learning, given this data set, we are able to learn and create a model that given inputs will predict results. So what exactly is the difference between this and using statistical analysis to create an algorithm? Well, an algorithm is a mathematical technique. So with traditional programming and algorithms, we take data and rules and use these to develop an algorithm that will give us answers. So in the previous example, if we were using a traditional algorithm, we would take the data such as beats per minute and BMI and use this data to create an algorithm that will determine whether the heart will fail or not. This algorithm, for example, could be saying something like beats per minute minus BMI equals a certain number, then the result will be true. Essentially, it will be an if-then-else statement. When you submit inputs, we will get answers based on what the algorithm we determined is. The thing is, the algorithm will not be changing. Machine learning, on the other hand, we take data and answers to create the algorithm. Then in the end, instead of getting answers, we already have the answers, we get a set of rules that determine what the machine learning model will be. So going back to the previous example, we would essentially look at the data, look at the results, develop an algorithm, which is the model that determines what the rules are, that determines what the if-then-else statement would be when we get inputs. Essentially what the model does is determines what the parameters are in a traditional algorithm. Instead of deciding arbitrarily that beats per minute minus BMI equals a certain result, we use the model to determine what that logic will be. This model, unlike a traditional algorithm, can be continuously trained and used by the future to predict values. This model, unlike a traditional algorithm, can be continuously trained and be used in the future to predict values. What exactly do we mean by training? How exactly is the algorithm determined? Training refers to using a learning algorithm to determine and develop the parameters of your model. While there are many algorithms to do this, in layman's terms, if you are training a model to tell from good or bad, you will be showing the algorithm a set of data and saying, "This data is good," then showing the algorithm again a second set of data and say, "This data is also good." And you will be repeating this process while the algorithm modifies internal values until it has learned to tell from the good and bad. With machine learning, we will take a data set and split it into three categories: training, validation, and testing. The training subsection will be the data used to train the algorithm. The validation subset will be used to validate our results to make sure that our validation fits the validation dataset. This is used to fine-tune the algorithm's parameters. Lastly, the testing data will be data the model has never seen before, used to evaluate how accurate our model is. Machine learning is a broad field, and we can split it up into 3 different categories: supervised learning, unsupervised learning, and reinforcement learning. There are many different tasks we can solve with these. Supervised learning refers to when we have class labels in the data set, and we use these to build the classification model. What this means is, when we receive data, it has labels that say what the data represents. In the previous example, we had a table with labels such as age or sex. With unsupervised learning, we don't have class labels, and we must discover class labels from unstructured data. This could involve things such as deep learning, looking at pictures to train our models, things like that. This is typically done with something called clustering. Reinforcement learning is a different subset, and what this does is it uses a reward function to penalize bad actions or reward good actions. Breaking down supervised learning, we can split it up into 3 categories: regression, classification, and neural networks. Regression models are built by looking at the relationships between features X and the result Y, where Y is a continuous variable. Essentially, regression estimates continuous values. Neural networks, on the other hand, refer to structures that imitate the structure of the human brain. Classification, on the other hand, focuses on discrete values. It identifies unique classes. We can assign discrete class labels Y based on many features X. The example we gave in the previous example was an example of classification, where the classes would be heart failure or a healthy heart. Some forms of classification include decision trees, support vector machines, logistic regression, and random forests. With the previous example, as said before, with classification, we extract features from the data. The features in this example would be beats per minute or age, as these are categories or classes. Features are distinctive properties of input patterns that help differentiating between categories of input patterns. Each column is a feature, and each row is a data point. Classification is the process of predicting the class of given data points. A classifier uses some training data to understand how given input variables relate to that class. Again, to review, a model is the algorithm used to find patterns in the data without the programmer having to explicitly program these patterns. And a feature is an individual measurable property or characteristic of a phenomenon being observed. Now that you understand the basics of AI, there are limitless industries where you can use them. Some industries include military, agriculture, music, healthcare, art, and more. Do you have any ideas what you would want to do involving artificial intelligence? Now that you understand the concepts of what AI and machine learning are, you can use Watson Studio and IBM Cloud to get started doing it yourself. Keep watching the future videos to figure out how.